In this video, we learn about prime numbers, what is a prime number and how to identify it. We'll learn by first defining what is a prime number and then we'll take a look at the examples. Now, how do we define a prime number? It has to satisfy two rules. Rule number one, it has to be a natural numbers. Natural numbers, we already know that these are the counting numbers starting from 1. So any number starting from 1 and so on is a natural number. So a prime number has to be a natural number. Rule number 2 is a prime number is exactly divisible by only two factors. That is, there are only two numbers which can divide the prime number completely, and one of the number is 1, the other number is itself or the number itself. These are the two rules which a prime number should satisfy. Now let's take a look at the examples. Let's take up 1 and find out, is 1 a prime number? We know 1 is divisible by itself, that is 1 into 1 gives us 1. So 1 is divisible only by 1, that means it has only one factor. So it does not satisfy our rule, the second rule, which actually says there has to be two factors, exactly two factors. So we conclude that 1 is not a prime number. We'll take up 2. Is 2 a prime number? We can write 2 as, we know that 2 is divisible by 1 and 2 is divisible by itself 2. These are the only two numbers which can divide 2 completely. So it has two factors, it's a natural number, so it satisfies both the rules of a prime number. So 2 is a prime number. Similarly, let's take up 3. So 3 is divisible by 1, 3 is divisible by itself. So there's no other number that can divide 3. So it has two factors. So it satisfies both the rules. So we conclude 3 is a prime number. Now how about 4? So we know 4 is divisible by 1 and 4 is divisible by 4. But we also know that 4 is also divisible by 2. So that means it has three factors, 1, 2 and 4. According to our rule number 2, there has to be exactly two factors. That's why 4 is not a prime number, because it has more than two factors. Let's take up 5. So 5 is divisible by 1, 5 is divisible by 5. So it has exactly two factors. And so we conclude that 5 is also a prime number. Let's take up 6. So 6 is divisible by 1, 6 is divisible by 6, but 6 is also divisible by 2 and 3, because we can write 6 as 2 into 3. So how many factors does 6 have? It has 1, 2, 3, 4 factors. So is 6 a prime number? No, because it has more than two factors. So 6 is not a prime number. Let's take another, a bigger number. Let's say we'll take up 12. So we know 12 is divisible by 1, it's divisible by 12 itself, and then there are many numbers in between which divide 12 completely. So we have 2, 4, 3 and also 6. So there are more factors for 12. So clearly 12 is not a prime number. It has totally 6 factors. Let's take another example, a slightly bigger number, and try to find out if it's a prime or not. We'll take up 51. So we know 51 is divisible by 1 and it's divisible by 51. So just by looking at it, we might get confused and think that 51 is a prime number and there are no numbers which can divide 51. But if we think again, we'll see that 51 can be written as 17 into 3. So 17 and 3 are also factors of 51. So 51 is not a prime number. By now you would have understood that if a number can be broken down into smaller numbers other than 1 or other than itself, then it is not a prime number. As you can see here, 4 can be broken down into 2 and 2. So it's not a prime number. Same thing with 6. We will now look at some even numbers and some odd numbers and try to find out if they are prime numbers or not. Let me list down all the even numbers first. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. And we have the odd numbers 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and so on. We'll just stop it here. Now, let's look at the even numbers. So we have 2. We already saw that 2 is a prime number because 2 has 2 factors, that is number 1 and 2, that is itself. So 2 is a prime number. I'll mark it. But if we look at all the other even numbers, starting from 4, by definition of an even number, we know that all even numbers are divisible by 2. So that means in addition to 1 and the number itself, there is another factor for all even numbers, that is number 2. So that means all these even numbers except 2 are not prime. So 2 is the only prime number which is also an even number. So except 2, all other even numbers are non-prime numbers. Now let's look at the odd numbers. We already saw that 1 is not a prime number because 1 has only one factor. Three has 2 factors. 3 is divisible by 1 and 3. So 3 is a prime number. So 5 has 1 and 5 as factors. So 5 is a prime number. 7 has 1 and 7. So 7 is a prime number. 9 has 1 and 9. In addition to that, 9 can also be written as 3 into 3. So 3 is another factor of 9. So totally 9 has 3 factors. That means it is not a prime number. 11 has 11 and 1. These are the only 2 factors. So 11 is a prime number. Similarly, 13 has 1 and 13. So it is a prime number. What about 15? 15 has 1, 15. But we can also write 15 as 5 into 3 or 3 into 5. So that means it has more factors than 2. So it is not a prime number. 17 has only 1 and 17 because there is no other number that can divide 17. So 17 is a prime number. Similarly, 19 has just 1 and 19 has the factors. So 19 is a prime number.